Hi guys, today I want to walk through a project I have built called AI Clinic Router. The idea behind this application is simple. A patient enters their symptoms, everything before anything, everything is built on the backend. I was not implementing any client side. Maybe I will do it later. Just for the visual, but for now it's the backend Spring Boot Supabase only. So a patient enters their symptoms. An AI model recommends the most appropriate medical department, and the application retrieves available doctors from PostgreSQL Supabase database. The project is built again with Java Spring Boot, Spring Data JPA, PostgreSQL, Supabase, Spring AI, and the DeepSeek API. But this video is not about building the project from scratch. It's about understanding the architecture behind it and why I made certain design decisions. I'm going through the project in this video, and I will explain what each file or class is responsible for, how the different layers work together, and why everything is organized the way it is. We will look at the controllers, services, repositories, entities, DTOs, validation, exception handling, AI integration, and everything else that make the application work. My goal is to build a complete understanding of the project by explaining every part of it in simple terms. So let's dive in. And before we dive into the project itself, there are just a couple of things you will need if you want to build it on your own. First, you will need a Supabase project with a PostgreSQL database. And second, you will need a DeepSeek API key, since that's the language model I'm using for AI routing in this project. I'm not going to cover the setup in this video because there are already plenty of tutorials showing how to create a Supabase project and obtain a DeepSeek API key. I also have videos where I go through the Supabase setup process step by step, so you can check my videos. For this walkthrough, I will assume those are already in place for you, so we can focus on the application itself and how everything works together. Here you can see the project configuration in Spring Initializer. For this project, I'm using Maven as the build tool, Java version 21. I'm also using the standard package structure and the application properties configuration file instead of YAML, simply because that's my personal preference. For the dependencies, I selected Spring Web to build the REST API, Spring Data JPA for database access, validation for validating incoming requests, PostgreSQL driver to connect to database, and Lombok, even though I have not been using Lombok in this project. Originally, I started this project using OpenAI dependency because I plan to use OpenAI as a language model. Later, I decided to switch to DeepSeek, so I replaced the OpenAI integration with the DeepSeek integration instead. You can keep using OpenAI if you want to. All you will need is to create the API key on the platform of OpenAI. That's the basic project setup, and now we can start looking at how the application is structured. Now let's take a quick look at the overall project structure. So inside of main package, which is this one right here for me, I have organized the application into several smaller packages, each with its own responsibility. The entity package contains the JPA entities that represent the database tables in this project. Those are department and doctor. The service package contains the application's business logic. Here you'll find the department service, doctor service, triage service, AI department service. I'll explain each of this in detail later, but for now, it's enough to know that this is where the application makes its decisions. The controller package contains the REST controllers. These are responsible for receiving HTTP requests and returning responses to the client. The repository package contains Spring Data JPA repositories. These interfaces communicate with the PostgreSQL database, while Spring Boot automatically generates their implementations at runtime. I also have a DTO package for request and response objects, an exception package for custom exceptions, and global exception handling. Inside of my DTO, you will also see the one enum file. We'll talk about that later. This file is for predefined department names. And of course, the resources folder with the application properties file. We'll look at that one also in a bit. This is fairly typical layered Spring Boot structure. Every package has a specific responsibility, which makes the application easier to understand, maintain, and extend later. Now we will go through each of these packages quickly, one by one, and look at what every class is doing. In this video, I'm going to focus only on the entity package. Entity already includes many important Java JPA database concepts, which I want to cover. And I don't want this video to be too long or overloaded, so I'm going to be dividing my videos. So in this video, I'll explain the entity classes in detail. And in my next videos, I'll continue with the other parts of the application, such as repositories, services, controllers, DTOs, validation, exception handling. We will also, I think in my next video, look at Supabase, because I'll show you to create two tables in the Supabase, the doctors table and department table, and connect it to the application. That's what we will do next. But for now, let's concentrate on this entity, namely doctors for now. So doctors entity. Here I have doctor's class, a doctor class. So this first line is showing where the class is located. Packages are used to organize classes based on their purpose. Because this class represents data stored in database, I placed it inside entity package. Next, I have this import. This imports the JPA annotations that I use in the class. The asterisk means that I'm importing all the required classes from this Jakarta persistence package. In my entity, I use annotations such as entity, such as table, ID, generated value, column, many-to-many annotation, join column annotation. All of these come from Jakarta persistence. Jakarta persistence is also commonly called JPA. JPA stands for Java Persistence API. It defines how Java objects can be mapped to relational database tables. An important distinction is that JPA is a specification. It defines the rules, annotations, and expected behavior, but it does not usually perform the database work by itself. Hibernate is the implementation that performs the actual work in Spring Boot application. So a simple way to understand the relationship is JPA defines the rules and Hibernate implements those rules. Spring Data JPA then provides another layer on top of JPA and Hibernate to make database access easier. Let's look at that annotation, the entity. The entity annotation tells JPA and Hibernate that this class represents persistence data. Persistent data means data that can be saved in database and still exist after application stops running. So without this annotation, without the entity annotation, this would simply be a normal Java class. Hibernate would not automatically map it to database table, track it, save it, or retrieve it. Because I use this annotation, the entity annotation, Hibernate understands that objects created from this class can represent rows in a database table. For example, one doctor object represents one doctor record in database. If the database table contains 10 doctors, Hibernate can convert those 10 rows into 10 doctor objects. This package is part of so-called ORM, Object-Relational Mapping. It means mapping Java objects to relational database structures. So the Java class maps to a table, Java fields map to columns, Java objects map to rows, for example. So next we have a table annotation. This annotation tells Hibernate which database table this entity belongs to. So in my situation, that is doctors. And in the next video, we will get to the Supabase, create the doctors table. And this way, doctors class will be mapped to the table in our Supabase. But we will look at that later. Java class name is singular because one object represents one doctor. The table name is plural because the table stores multiple doctors. This is a common naming style, although it's not required. If I don't use table or add table annotation, Hibernate could try to generate the table name based on the class name. So then you can see I declare this class, the class doctor. It's public, which means it can be accessed from other packages in the application. For example, my service classes repositories, my DTO mapping code can work with doctor class very well. Inside this class, I have fields such as ID, name, specialization, available, department. These fields describe the information stored for each doctor. So ID is a unique identifier for each doctor. The annotation at ID tells JPA that this field is the primary key for the entity. A primary key uniquely identifies each row in a table. For example, two doctors could theoretically have the same name, but they should never have the same ID. Even if two doctors have the same name, they remain different database records because their IDs are different. This is why the ID is important. The next annotation is generated value. Strategy generation type identity. This tells JPA that the ID should be generated automatically. I do not manually decide that one doctor should have ID 1, another doctor should have ID 2. The database generates the IDs when the doctors are inserted. The strategy I use is identity. With the identity strategy, PostgreSQL generates the value for the primary key. For example, when Hibernate inserts a doctor, it sends the doctor's name, specialization, availability, department to PostgreSQL. PostgreSQL creates the row and generates the ID. Before saving the doctor, the ID may be null. After saving it, the ID may become something like 7, 12, depending on the next value generated by the database. So here, field type is long. It's notable to say it's not a primitive type, which would be written like this, long. I capitalize it. Well, it starts with a capital letter. So the difference is it's a wrapper type and it can contain null. A primitive long, which starts with a small letter, cannot contain null. Its default value is 0. So here long is more appropriate. This field is also marked as private. This is related to what we know in Java as encapsulation. Encapsulation means that the internal data of an object is hidden and controlled by the class itself. Other classes should not be able to access the field directly. Instead, they access the field, private fields, through methods like getters. This allows the class to control how its state is accessed or modified. So then we have a field called name. It's also private. It's a column. In our database, we will have it as nullable, so it means that the database column should not allow null value. A doctor record should not exist without a name. So here, nullable equals to false prevents SQL null value. So the next one is this field. This stores doctors' specializations. For example, those can be cardiologist, general practitioner, orthopedic doctor, things like that. I don't have a column annotation about this field. That does not mean Hibernate ignores it. Because this is an entity field, Hibernate maps it automatically to database column using the default configuration. So I would use add column if I wanted to customize this field. I could have things like like that. That will be customization. The length could be this, non-nullable, etc. But I don't want to have it here. Then we have this field right here, which is a Boolean, and the field is called available. This field shows whether the doctor is currently available. Because it's a Boolean, it can normally have one of two values, true or false. In this application, true means that the doctor is available, and false means the doctor is not available. This allows the application to retrieve only available doctors after the AI recommends a department. For example, the AI may recommend cardiology, but the application should not automatically return every cardiologist. It should return cardiologist whose availability is true. So in this situation, I have Boolean as a primitive instead of a wrapper class. And wrapper class would start with a capital letter. A primitive Boolean always has a value. Its default value is false. A Boolean wrapper can have three possible states: true, false, and null. For this application, availability should not be unknown. A doctor should either be available or unavailable. That is why primitive Boolean makes sense here. Also, I make sure here that the database value should not be null. Then we move to department relationship. Maybe I should stop here and move to department real quickly. It's pretty much the same. It has entity table, which is departments. It has the department class has fields like ID, name, description. Then it has constructors, getters, and setters. So coming back to my doctor class, this field represents the relationship between a doctor and a department. A doctor belongs to a department. For example, cardiologist belongs to the cardiology department. Dermatologist belongs to dermatology department. Java field type is not a string and not a department ID. It's actually department object, which means that in Java, the doctor is connected to department entity, which I just showed here. In the relational database, the connection is represented by a foreign key. So many to one is, which means many doctors can belong to one department. For example, one cardiology department may contain several doctors. Each doctor belongs to one department, but the same department can be connected to many doctors. That's why I have many to one relationship. So here I have fetch lazy, and that controls when the related department is loaded. Lazy loading means Hibernate does not necessarily load the complete department object immediately after time it loads all the doctors. Suppose the application retrieves a doctor and only needs the doctor's name and specialization. There may be no reason to immediately query the database for the department as well. With lazy loading, Hibernate can delay loading the department until the application actually accesses it. This is to improve performance by avoiding unnecessary database work. So the next we have at join column. This tells Hibernate how the relationship is stored in a database. The foreign key column is located in the doctors table and is called department ID. A doctor's row might look like ID2, name Dr. Brown, specialization cardiologist, available true, department ID 1. The value in department ID refers to the ID of a record in the department table. For example, Cardiology is under ID 1. So when the doctor has department ID 1, database knows that the doctor belongs to the department whose ID is 1. So again, a foreign key is a column that refers to the primary key of another table. The primary key identifies a record inside its own table, and the foreign key creates a relationship with a record in that table. The doctor's entity is considered the owning side of the relationship because the foreign key is stored in the doctor's table. The owing side is the side that controls the relationship in a database. Because department ID is stored with the doctor owns this relationship. Then I have constructors. After the fields, so you have this, this one is no argument constructor. It creates a doctor object without requiring any values. This constructor is important because JPA and Hibernate need a no argument constructor to create entity object when they read data from database. Hibernate retrieves a database raw and needs to create a corresponding Java object. It can initialize, it can instantiate the class using the empty constructor and then populate the fields. The no argument constructor must normally be public and protected. In this project, I made it public. In more restrictive design, I could make it protected. This would still allow JPA to use it. It is important to understand the difference between no argument constructor and a default constructor. No argument constructor is any constructor that takes no arguments, and default constructor is a no argument constructor automatically generated by Java. Java only generates that constructor when I do not write any constructors myself. Because I created a parameterized constructor, Java would no longer automatically create an empty constructor. Therefore, I had to write this constructor explicitly for JPA. The second constructor is parameterized constructor. It allows me to create doctor and provide the important information immediately. The ID is not included in this constructor, and this is intentional. The ID is generated by database. When I create a new doctor, the doctor does not have an ID initially. I provide the name, specialization, availability, department. Then I save the entity. PostgreSQL generates the ID for me. So in my constructor, I have lines like this. This name, for example, here, refers to the field that belongs to the current object. The second one, which is name, refers to the constructor parameter. It pretty much means take the value received by the constructor and assign it to the current doctor or current doctor's name field. The keyword this refers to the current object, and the same is used for everything, every other field. Having two constructors with different parameters is called constructor overloading. These constructors have the same class name, which is doctor, but one receives no arguments and the other receives 4 arguments. Java then chooses the correct constructor based on how I create the object. After the constructor, I have getters. So a getter allows another part of the application to read the value of private field. So getters allow services, DTOs, etc. to read the data from doctors class. And of course, I also have setters. A setter allows another part of the application to change the value of a private field. So the setter receives a new value and assigns it to the field. Setter returns void. That means it performs an action but does not return any value. Its purpose is to update the object. For example, a doctor may move to another department. When an entity is managed by Hibernate inside a transaction, Hibernate tracks changes made to it. For example, if I retrieve a doctor from the database and then call doctor.setAvailable false, Hibernate can detect that the value changed. When the transaction is committed, Hibernate can automatically generate SQL update. This mechanism is called dirty checking. The entity is considered dirty because its current state differs from the state originally loaded from the database. Hibernate detects the change and synchronizes it with the database. Although setters are common, it is not always necessary to expose setter to every field. So why I did not use Lombok here? I included Lombok as a project dependency, but in my entity, I wrote the constructors, getters, setters manually, even though Lombok is always preferred. All you would need to do is have annotations like at getter, at setter, at no arg constructor. This would reduce boilerplate code, which means repetitive code that is necessary but does not contain much unique business logic. So in my project, I decided to write them all explicitly to make the structure of the entity visible. So Lombok reduces code, but developers still need to understand exactly what it generates. So it needs to be used carefully. For example, automatically generated toString equals hashcode methods may cause issues with lazy loaded relationships or bidirectional entity relationships. A generated toString method might try to access the department. Bidirectional relationship could also cause recursive method calls. Alright guys, I'm finishing here. I will see you in my next videos where we will continue. Till next time.